If stoichiometry feels confusing, it usually comes down to mole ratios. In this video, I'm going to explain what mole ratios are and how to find them from a balanced equation step by step. Let's start then with this reaction here, where we have N2 plus 3H2 reacts to give 2NH3. What does it tell us? It tells us that one molecule of N2 reacts with 3 molecules of H2 to form 2 molecules of NH3. This is known as a molecular ratio because it gives us information about what's reacting and what's being produced in our reaction. So we can use this molecular ratio to figure out how many molecules of something we need or how many molecules of something we produce when we're given one of the other values. So for example, if we had 2 molecules now of N2, it means that we would need 2 times 3, or 6 molecules of H2, and we would produce 2 times 2, or 4 molecules of ammonia. And so we can use this molecular ratio in this way. Let's take this a step further now and look at a little bit more of a complex problem. So in this one, we're asked how many molecules of ammonia are produced from 20 molecules of nitrogen gas. So what I first kind of like to do is come in here and highlight what I'm looking for. So I'm looking for, or actually I'm given that I have 20 molecules of nitrogen gas. And let's pick a different color. We've got ammonia that we're looking for. We're asked how many molecules of ammonia are produced. Okay, so keeping our color coding then, we can actually set up our ratio. And the way that I like to set up ratios is to set up fractions on each side of an equation to make it really easy to solve for. So it doesn't matter what you put on top, what you put on bottom, as long as you're consistent from side to side. Let's take a look and see what I actually mean about that so we can see an example. So on one side of our, let's grab the pen, one side of our equation, we're going to take our known ratios from our balanced chemical equation. So we know that one, and I need my pen here again. Okay, 1 molecule of N2 is used for every 2 molecules of NH3 that is made. So this is our known values from our balanced chemical equation. On the other side of the equation, we're going to set it up so that we've got our value we're given in our problem, as well as what we're trying to solve for. So if I have, and let's just double check the color coding here, nitrogen gas on the top in blue, it means I need nitrogen gas on top on this side too. And if I have ammonia on this side, on the bottom, I need to make sure ammonia is on the bottom here as well. So I'm going to kind of color code those for myself just so that I know what I'm doing. And then taking from the problem, we have 20 molecules of N2. And the blues are matching, so we're good. And then we don't know how many molecules we are making of NH3, so I'm going to use X there. At this point, it becomes cross multiplication. So we're going to cross multiply on each side. So we're going to end up with 1x is equal to 2 times 20, or x is equal to 40, and that is 40 molecules of NH3. Now that was a really easy ratio to solve for, but when they do get more complex, it's really important that we go through the same process of setting it up to solve for our answer. Now this video is all about mole ratios, and you might be like, okay, we're talking about molecular ratios, so when are we going to get to mole ratios? Well, let's get to it. Let's take this equation further. We know 1 molecule and 3 molecules of N2 and H2 react to make 2 molecules of NH3, what if we multiplied all of these molecule values by Avogadro's constant here? Well, if we did that, we'd have 6.02 times 10 to the 23 molecules of N2. We'd have 3 times 6.02 times 10 to the 23 molecules of H2, and so on. And we know that if we have 6.02 times 10 to the 23 of something, we have 1 mole of it. So these become then mole ratios. We have 1 mole of N2 reacts with 3 moles of H2, and it produces 2 moles of NH3. Now, this is just another way to represent a ratio using the semicolons or colons, sorry, in between each of the numbers. Now, this is a mole ratio. And mole ratios are really important in stoichiometry, and we're going to see that in future videos because they're going to help us figure out the moles that are produced or needed for any chemical reaction if we're given just one of the values. And that is a very powerful concept. So let's see mole ratios in action. We've got this problem here where we're asked how many moles of ammonia are produced from 2.8 moles of hydrogen gas. So let's just highlight we need hydrogen gas here. So that's here in our equation. And then we also need ammonia, and that's here in our equation. All right, so now that we've highlighted those, it's going to help us to build our mole ratio. So again, I'm setting up on one side what we know about the ratio from our balanced chemical equation. So we know we have 3 moles of H2, and we know that we produce 2 moles of NH3. And then on the other side, we're going to set it up so that we have moles of H2, and that's given to us at 2.8 moles of H2. Okay, remember, moles of H2 have to be both on the top, and they are. And then we're trying to find the moles of NH3. Now, I could have set this up with ammonia on top on both sides, and that would be totally fine. So it's okay as long as you're being consistent and making sure if ammonia is on the bottom here, then ammonia is on the bottom on the other side too, and vice versa. Okay, so solving here, we're going to cross multiply, so we get 3x, and then we get 2 times 2.8, or x, if we divide both sides by 3, gives us 1.9, and that's moles of ammonia. Now, one thing I want you to keep in mind is it's really important to make sure you're selecting the correct ratios. So highlighting your known and your unknown in the problem and in your balanced chemical equation can help you identify these really quickly and clearly. So it may seem silly taking that little bit of extra time, but it is totally worth it to make sure you do not make a mistake. Let's do one more example, a little bit complicated. This one asks us how many moles of water are required to react with 2.3 moles of magnesium nitride. So again, let's get out our handy highlighter. We need moles of water, that's what we're trying to find. So there it is in our equation. Seems fitting that we're using blue for water. And then we need magnesium nitride. We're given 2.3 moles and it's right there. Okay, so now that we've got that, I'm going to set up from our balanced chemical equation that we have 1 mole of magnesium nitride reacts with 6 moles of water. And then from our problem, we're given 2.3 moles of magnesium nitride. And we're trying to find our moles of water. So double checking, magnesium nitride's up on the top, water is on the bottom on both sides, so we're good. We're going to cross multiply here then to solve for x. So we get 1 times x, or just x, is going to be equal to 2.3 times 6 And that is going to give us 13.8 moles of water. So that's all to it. You just got to double check, make sure you're setting up your mole ratio in the right way. But if you're comfortable with mole ratios now, the next video in the series is going to show you how to use mole ratios to solve mole-to-mole stoichiometry problems. So go check it out. It's linked on the screen now, and we'll see you there.